Hello everyone. Today we will be discussing Unit 2, and Unit 2 is about data organization and graphical representation. So first we'll start with the basic overview of this unit. So this unit will consist of these following topics. We'll start with data organization and graphical representation. Then we'll move on to classification and tabulation of qualitative and quantitative data. Then we'll be discussing construction of frequency distribution, followed by cumulative frequency distribution. And then we'll conclude by discussing percentile and percentile ranks and graphical representation of data. Okay, so let us start. So first of all, we should know what do you mean by classification and tabulation of quantitative and qualitative data. Before moving into that, we should know what is qualitative data and what is quantitative data. So any data, it can be either quantitative in nature or it can be qualitative in nature. What is qualitative data? Qualitative data is basically a categorical data. Okay, so there are several categories involved. Okay, like for example, it can be texture of your hair. Okay, whether your hair is silky, whether your hair is smooth or it is dry. So there are three categories. So this is a categorical variable, or it can be gender. Okay, so whether you are male or you are female. So such variables in which there are various categories, or which zone do you belong to, like north zone, south zone, east zone, west zone. So these are such variables are called qualitative variables or categorical variables. Then we move on to another variable, which is the quantitative data. So quantitative data basically consists of numbers and it can be measured. Okay, for example, like what's your weight? Okay, so weight can be anything ranging from any number like 20 kg, 56 kg. So all these can be measured, or your height. Okay, height is also a quantitative data. It is involving numbers. Or what is the size of your shoe, what is the length of fingernail, what is the length of a fingernail, what is your income, what is say. So all these data which involve numbers comes under quantitative data. Okay, so these are the two basic type of data, and then we move on to univariate data. Univariate data is the data which involves only one variable, only single variable. So that is the univariate data. Now we come to classification. As the name suggests, classification is the method of organizing the data into groups or classes. Okay, so what happens? There is the data and you divide it into several groups. So within each group, the data points will be similar to each other. Okay, but as a group, they will be different from the other group. Okay, so you will be dividing the data into several groups, and each group is homogeneous with respect to that group, but it will be a little bit different from that group. Okay, so for example, if you are visiting some foreign countries, then for example, group of Indians will be one group of Australians will be another group, or group of Bangladeshis will be another group. So there are subgroups within a particular group. So this is classification. You are classifying data according to some measures. Okay, so what happens in the context of research? The data is collected by the researchers and he organizes the data into classes or groups so that it becomes easy for him to draw the conclusions or to understand the data better. So he will classify the data based on the similarities as we have discussed. Okay, so there are some objectives of classification. There are some advantages of classification. Let us discuss those examples. Okay, let us see what are the advantages of classification here. So the first classification is the data is presented in a concise form. Okay, a precise form, because if a data is raw, it will have no meaning. Okay, I've just given raw data, you will not understand, you will not know what to do from that data. So to present in the concise form, this is the first objective of classification. Once it is classified, at least you will be able to make some sense of the data. You will be able to classify the data. Okay, now, then the second is classification helps in identifying the similarities and diversities in the data. Okay, so if you know, okay, the data is classified according to this attribute, then I know that what this group is about, I know what this group is about. Okay, for example, if you are getting marks in a particular subject, then those marks can be classified. Okay, for example, the students who obtain the marks between 1 to 25 will be classified in another group. The students who are obtaining marks between 26 and 50 will be classified in another group. The students who are obtaining marks between 51 to 75 will be classified in another group, and so on. So in this way, classification makes it easy to identify the data. The third is, so let us see this table. So as you can see, we can see the students and the marks obtained by the students. So there are several classes in which the marks is divided, and you are corresponding to that class, you're getting the number of students there. Okay, so this is how classification is done. It will be used again and again in statistics, and it becomes very easy to work with such classified data. Okay, now let us see more examples, more advantages of classification. So classification also helps in comparison. So once you have obtained the groups, then you can compare one group with another. Okay, so for example, computation of percentage will tell us the percentage of students falling in each group. So for each student, you know the number of students. For each group, you can calculate the percentage. So you know how many percentage of students will fall in which group. Okay, which percentage of students falling in higher marks group, or which percentage is falling in lower marks groups, and so on. Then classification can be carried out for qualitative as well as quantitative data. Okay, for example, individuals can be classified on the basis of their color of their hair. Okay, whether it is gray hair, or it is white hair, or it is golden hair, or it is black hair. So individual can be classified on the basis of that. That is qualitative data. Okay, and you can also classify the people on the basis of quantitative data. For example, you can classify high income group separately, low income group separately, middle income group separately, or you can classify on the basis of age. So classification can be done both on the basis of qualitative data as well as quantitative data. Okay, now let us see what is tabulation. Okay, tabulation is nothing but you have to construct a table out of the data. Means you have to express the data in tabular form. Okay, so a table, what is a table? You have seen a table many times. It is the arrangement of data in the form of row and columns. Okay, where rows are horizontal arrangement and columns are the vertical arrangement. And the table can be simple or complex depending upon what type of data you are dealing with. Okay, let us see more about tabulation. So the most important aspect of tabulation is tables. Okay, there are several aspects of table or components of table. Let us discuss those components. Okay, first is table number. See, numbering a table is very important. Okay, because if you will not number a table, then if you want to refer to that table again in your thesis or your project report, then how will you refer to that table? So numbering a table is very important, and you will see here again and again in this presentation or in the future presentations that tables will be numbered. Okay, then comes the title of the table. So a title of the table, it's very important, and it should be very specific in nature. So the title will represent basically what the table is about. Reading the title of the table only should be clear that, oh, okay, this table is telling about this thing. So it should be self-explanatory, and the reader can easily understand what the table is about. So this is the main function of the title. Okay, next coming to captions and stub. Okay, so any table will have rows and columns based on its content. Okay, so heading givens for columns are known as captions, and stubs are the headings which are given for rows. We'll see an example of the table in which there will be captions and stub. Okay, so these again need to be very concise and self-explanatory. Okay, there should be not very long captions and stuff. It should be concise and it should be self-explanatory. Okay, and the captions and stuff can be decided by the researcher based on his research on which he or she is carrying out. Then comes the body of the table. So the body of the table will contain all the numerical information data that is you have obtained on the basis of data collection. Okay, so the numerical data here will be classified into captions and stubs. Okay, so we'll see an example of this. Now, what is a head note? So tables also have head notes which could be written in extreme right below the title, and they provide information about the units of measurement. So suppose there are units of measurement involved in your table, then you can use head notes. Footnotes are written below the table, and they display very crucial information about the information given in the caption and stub. Okay, so the information which you cannot directly mention in the table, you can mention it in the footnote. Source of data, mentioning source of data is very important. From where have you got the data source? Okay, if you will not mention the source of data, sometimes in thesis or report, it is considered as a plagiarism. So it's very important, whatever diagram you are putting, even in the diagrams also, you have to mention the source. Tables also, you have to mention the source. So mentioning the source of data, that from where you have collected the data, it is very important. Okay, so let us see this table which is prepared. Okay, and we will see various aspects of the table. It will be clear that how to name a table. Okay, first of all comes the table title. So if you can see here that the title of the table is the percentage of male and female student based on marks obtained by them in English test. Okay, so here in columns you can see the marks obtained in English, that is the stub head. Okay, and then that gender is divided into males and females. Here gender is the qualitative variable, okay, which is divided into males or females. Here you can see the heading for rows are the heading for rows are the stubs, and the heading for columns are the captions. You can also see a footnote. Footnote mentions the number of students in terms of percentage, that is the unit. Source is from where you have got that data. So source is the data collected from term and examination results. Okay, so this is how you prepare a table. So this is an example of a table. Now, let us study some merits of classification and tabulation. The first important advantage of classification and tabulation is that it clarifies the data. It makes the data very clear. The information in the data becomes easily accessible, and it provides adequate information about the data. So it clarifies the data. The second is it simplifies the data. Okay, so when data is presented in a table, you can easily make out what the data is about, rather than if it is written in long paragraphs. So it simplifies the data. Okay, then we come to comparison. Okay, so when the data is in the form of rows and columns, you can easily compare the two rows. Okay, for example, you can find out the percentage, you can find out the fraction. So you can find out, okay, in this attribute, this person has more marks or this person has less marks. So comparison can be made, and information can be easily referred to. You can easily refer to the information when it is in the form of tables. Now let us study what is a frequency distribution. So it is frequency distribution is closely connected with the tables which we have studied. Okay, so frequency distribution is the way in which raw data can be classified so as to provide a clear understanding of the data. So it is basically a tabular representation in which the raw data, you'll organize the raw data into intervals, class intervals. Okay, we'll study in detail what are class intervals and how to construct class intervals. But for now, you can understand that it is a way to classify the data into tables. Okay, now let us see. So frequency distribution can be characterized into basically three types. Okay, the first is the relative frequency distribution. What is a relative frequency distribution is that the score is allotted to each class interval, and you can find the proportion of total number of cases in a distribution. For example, if there are 100 employees, okay, in 100 employees in an organization, and 35 employees fall in certain range of, suppose, in 10 to 14 years of experience, then what will be the relative frequency distribution? You have to just divide 35 by 100, the total number of employees. Or suppose there is some other class interval of suppose freshers, like 2 to 4 years of experience. So there are around 20 people. So the relative frequency distribution for that will be 20 divided by 100. So in that way, you can find the relative frequency distribution. Okay, now coming to cumulative frequency distribution. So cumulative means summation. So whenever cumulative comes, you have to understand that it is summation. So such a distribution for a class interval is the summation of frequencies for the class interval which lies below that class interval. Okay, so for the classes which are lying below that class interval, you have to sum. You have to find the sum. We'll see an example of this, and we will calculate all the attributes like relative frequency distribution, cumulative frequency distribution. We'll calculate, and I'll tell you how to find out. Okay, now what is cumulative relative frequency distribution? So in such a distribution, the cumulative relative frequency of a particular score is the relative frequency for that score in summation with the relative frequencies of all the scores. So here cumulative is sum. Cumulative relative frequency distribution means sum of the relative frequency distribution which is lying below that or before that particular score. So again, we see in examples that how do we calculate such type of distributions like cumulative frequency distribution, relative frequency distribution, or cumulative relative frequency distribution. Okay. So the next example which we will see is that how to calculate these relative frequency distribution. Now let us see these examples of relative frequency, cumulative frequency, and cumulative relative frequency distributions. Okay, so in this table, we are given the scores or the marks, and we are given the corresponding frequencies. So here the scores are 34, 23, 22, 21, and 19. And frequency is corresponding to score 34, the frequency is 3. This means 3 students have got marks 34. Okay. Similarly, 4 students have got 23 marks, 10 students have got 22 marks, and so on. So these are the scores and these are the frequencies. Now let us calculate the relative frequency. So these are the relative frequencies. Okay, so how have we got this 10%? So this is equal to, this is 3 divided by the total, that is 3 divided by 30 into 100. Okay, so what you will do, you will cancel 0 and 0 from here. 3 and 3 will cancel out, so you will get 10%. Similarly, how are you getting this 13.33? That is equals to 4 divided by 30 into 100. So you will get 13.33. Similarly, this, how you will get 33.33? That will be 10 divided by 30 into 100. Similarly, 20% will be 6 divided by 30 into 100. Okay, and here 23.33% will be 7 divided by 33 into 100. So this is how you calculate the relative frequency. Now to calculate the cumulative frequency, what you have to do, so this is 30. So 30 is the total frequency, that is n is equals to 30. Now to calculate 27, you have to sum 4 plus 10 plus 6 plus 7. That is sum of that class and all the classes that follow it. So that is 4 plus 10 plus 16 plus 7. So 14 plus 6, 20 plus 7, that is 27. Then how you will get this 23? 23 will be 10 plus 6 plus 7. That is 16 plus 7, that is 23. Then 13 will be 7 plus 6, that is 13. And 7 will be 7. So this is how you calculate the cumulative frequency. Now to calculate the cumulative relative frequency, how you will calculate? So this is 30 cumulative frequency divided by total into 100. So that will be 30. This 30 divided by this 30 into 30 divided by 30 into 100. So you will get 100%. Similarly, how you will get 89.99%? So that will be this 27 divided by 30. Okay, so this will be 27 divided by 30 into 100. That is 89.99%. Okay, now this will be 23 divided by 30. This will be 23 divided by 30 into 100. So that will be 76.66%. So this is how we calculate the relative frequencies, cumulative relative frequency and cumulative relative frequency distributions. Okay, now let us see, after seeing this, let us see what is meant by exclusive. So there are in frequency distribution, there are two main methods to describe class interval. The first is the exclusive method and the second is the inclusive method. Okay, first we will discuss what is meant by the exclusive method. So what happens in exclusive method? In exclusive class intervals, the upper limit of one class is same as the lower limit of the succeeding class. Okay, let me give an example. So suppose these are classes, okay, and this is the corresponding frequency. Okay, so you have the class, like you have the class 10 to 20 and the corresponding frequency is 2. Similarly, you have a class 20 to 30 and the corresponding frequency is 5. Similarly, you have a class 30 to 40 and the corresponding frequency is 1. So what is happening here? If you can see, the upper limit of one class is same as the lower limit of the other class. So such type of intervals are called as exclusive class intervals or exclusive method. This is known as the exclusive method. Okay, now let us see what is meant by the inclusive method. Now, please be very careful and listen that in inclusive method, the lower limit of the class interval does not get repeated in the upper limit of the preceding class. Okay, so when the distribution is in the inclusive form, it has to be converted to exclusive form. Now, let me first, I'll give you an example, and then we will see how to convert an inclusive class into an exclusive class. Okay, so in order to convert an inclusive class to exclusive class, you have to subtract 0.5 from the lower class limit and add 0.5 to the upper class limit. So first I will give an example so it will be clear. So suppose these are the classes. Okay, and this is the frequencies. Okay, so here the classes are 10 to 19 and the corresponding frequency is 2. Okay, here the class is 20 to 29 and the corresponding frequency is 5. Okay, here the class is 30 to 39 and the corresponding frequency is 1. Okay, so these are the inclusive classes. Why they are inclusive classes? Because the lower limit of the class interval is not getting this, see, this 20 is not getting repeated in this class. So this is an inclusive class. So you have to convert this inclusive into exclusive class. So how you will do it? You have to subtract 0.5 from the lower class limit and add 0.5 from the upper class limit. So it will be adjusted class here. Okay, adjusted class. So adjusted class will be subtract 0.5 from 10, you will get 9.5. Okay, then you have to add 0.5 to 19, so you will get 19.5. Similarly, subtract 0.5 from 20, so you will get 19.5. Again, you have to add 0.5 to 29, so it will be 29.5. Again, you have to subtract 0.5 from 30, so again, it will be 29.5. And then you have to add 0.5 to 39, so it will be 39.5. So this is how you convert an inclusive class to an exclusive class. Okay, so now this will be the new lower limit and this will be the upper limit. Okay, you have to remember this. This is how we explain the inclusive class and the exclusive class. So you have to be very clear for this. Okay, so you have to be very clear in this, that what is an inclusive class and what is an exclusive class. So now we will discuss what is meant by ungrouped frequency distribution. Okay, so an ungrouped frequency distribution is the one in which all the values are listed in either ascending order or a descending order. Okay, so based on the frequency of occurrence of each score, a tally mark is denoted by a slanting line, is placed in front of the respective value and the frequency is denoted by F. Okay, now suppose this is an example of an ungrouped frequency distribution. So these are the values which are given by 6, 9, 12, 13, 24. Okay, and these are the last is the corresponding frequencies. Okay, so the frequencies are here like 3, 4, 5, 1 and 2. Okay, now so this is given. Now you have to draw tally mark. Okay, so to draw a tally mark, what do? You draw a slanting line. Okay, so you will draw a slanting line for one tally mark. Okay, now for example, if you have 5 tally marks, you have reached up to 5. Okay, then 5. So for 3, you will draw 3. Yeah, here you will draw 3 slanting lines. For 4, you will draw here 4 slanting lines. Okay, but what happens for 5? So when you, the general convention is that for 5, how you will draw the tally marks? You will draw the 4 slanting line, 1, 2, 3 and 4. And the 5th will be a horizontal line. So this whole thing will denote 5. Okay, now, so this is denoting 4 slanting line and 1 horizontal line. Then this is 1 denoted by 1 slanting line and this is 2 which is denoted by 2 slanting line. So this is an ungrouped frequency distribution. Now, what is a group frequency distribution? Okay, so sometimes what happens, the data is very large, okay, and you cannot write it in a ungrouped form. So what do? To get a clear understanding of the data, we use a group frequency distribution. So here you group the frequencies into class intervals like into 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25. So these are the values, these are the classes in which you have grouped the scores. So suppose now F is 3 here. F3 means that 3 students suppose have obtained the marks between 1 to 5. Similarly, 5 students have obtained the marks between 6 to 10. 2 students have obtained marks between 11 to 15. one student has obtained the mark between 16 to 20, and again one student has obtained the marks between 21 to 25. So again, as we discussed before, you have to draw the tally. For 3, you will draw 3 slanting lines. For 5, you will draw 4 slanting lines and 1 horizontal line. Then for 2, there will be 2 slanting lines. Then for 1, again the one slanting line. Again here for 1, there will be 1 slanting line. So this is how the grouped frequency distribution is done. Now let us see another example. Okay, so suppose in a class of 40 students, following marks were obtained on a test of 10 marks. The marks obtained by 40 students are given as follows. So this is the marks obtained by 40 students. Now what you have to do, you have to create a frequency distribution on the basis of the raw scores. So on the basis of these scores, you have to create a frequency distribution. Now let us see how we do it. Okay, so first of all, so this is how you have to make a table. So frequency distribution using a tally method. Okay, so first we'll go through the steps and then I'll explain you how it is done. So first you have to arrange the data in ascending or descending order. Okay, so you have arranged the data in ascending order, like small to large. Okay, then what you have to do, so you have, see here, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here you have arranged 0, 1, 2, 3, 4 up to 10. So this is, you have arranged the data in ascending or descending order. So this is ascending order. Now you have to make a table with 3 columns, okay, and name them as a variable. So what will be the 3 columns here? The first column will be the marks column, okay. The second column will be the tallies column. The third column will be the frequency column. Okay, now what you have to do, let us see the next step. So you have made the columns. Now you have to enter your variables in the first column from lowest to highest order. So this you have already done. You have entered your variables in the first column from lowest to highest order, that is ascending order. This you have done. Now let us see what's the next step. So now you have to go one by one through the table and make a mark for each variable next to its value in the second column of the table. Then you have to count the tally marks for each variable and write its total in the third column, that is the frequency column. So let us see how this is done. Okay. So for 0 marks, how many students have obtained 0 marks? Let us check. So only one student has obtained 0 marks here. Okay. So you would put 1 against the 0 marks. So this frequency will be 1. Then how many students have obtained 1 mark? Let us see. So here in this, you can see 2 students have obtained 1 mark. So you will put a 2 corresponding to 1. Okay, then how many students have obtained 2 marks? Let us see, go back and see. 2 marks has anyone obtained here? As you can see, none of the students have obtained 2 marks. So you have to put a 0 against 2. Again for 3, how many students have obtained 3 marks? Let us check. So here 1, 2, 3. So 1, 2, 1, 2, 3, 4. The 4 threes. So 1, 2, 3, 4. So 4 students have obtained 3 marks. So again, you put a 4 here. So similarly, for all the marks, you have to write the frequency. And then you have to total the frequency. So total is 1 plus 2 plus 0 plus 4 up till 1. So it will be 40. Okay, again. So this is how you construct the frequency. So this is how you construct the frequency. Now you have to write the tallies. As I told you, you have to write the tallies corresponding to each. So for 1, you will put a 1 slanting line. For 2, again, you will put a 2 slanting line. Then again for 5, as I told you, 4 slanting line and 1 horizontal line. Now this 9 will be 5 plus 4, that is 9. Again, this 8 will be 5 plus 3, that is 8. This will be 5 plus 2, that is 7. So this is how you write the tally marks. So when there are no tally marks, 0, then you don't have to put any mark here. Okay, so that this will remain empty. So this is how you compute a ungrouped frequency distribution. Right? So these are the steps which we just discussed. Now let us see how to compute a grouped frequency distribution. So to understand this method, let us take another example. So suppose you have scores obtained by students in class test in history. So these are the scores which has been obtained by the students in a class test in history. Now there are several steps. Okay. The first step is, so step 1 is you have to find the range. Okay. So what is range? range is the highest value minus lowest value. Okay, so highest value, what is the highest value here? 35. See here, but there is no number greater than 35. The highest value is 35. Let us see. This is the highest value. What is the lowest value here? This is the lowest value. Okay, so you have to find the range. That will be 35 minus 1. That will be equal to 34. So range will be the difference of the highest score minus lower score. Okay, now the second step is we have to determine the class intervals. Okay, so we have to determine the class intervals. How to determine the class intervals? So this is the formula, okay, to determine the class intervals. So let me explain this. So the class interval is denoted by I. So I is equal to range upon number of categories needed. Okay, so the formula for interval is to determine the class interval is range upon number of category needed. Okay, so what happens? We usually have 6 to 20 classes of equal length. Okay, so we can have like 6 class, the length can be 6, 5, 6 up to 20. But if the scores are quite large, we can have the class intervals as 10 up to 20. So it depends upon your data and what is the length of the interval you want. Okay, so suppose you want the number of categories as 6. Okay, suppose you want the number of categories as 6. So I will be range upon 34 divided by 6. That will be 5.7. Okay, now you can round it off to 6. So the class interval can be of length 6 in this case. Okay, so once you have calculated the length of the class interval, then you have to create the frequency distribution table. Again, the frequency distribution table, it is similar to the steps which we did in the previous example. Okay, so I will explain you each of these steps again in detail. So each interval of length 6. Okay, so 31, 32, 33, 34, 35, and 36. Each is of length 6. Okay, now you have to find the frequency. So again, as the method I explained in the previous example, you have to find how many students have obtained marks between 31 to 36. Okay, let us see from this what the data is given, 31 to 36. Let us see. So 31 to 36 means greater than 31 and less than 36. Let us see. So this, I think this is only 35 is the only marks which is greater than 31 and less than 36. So there's only one. So frequency corresponding to that interval will be 1 here. Okay, see this. Okay, now for this, how many students have obtained marks between 25 to 30? Let us see how many students have obtained marks between 25 to 30. So 25 to 30, let us see. So 25, 1 is this 30. And then, so 25 to 30 here, it will be, 1 second. So there are 2 30s. So there, yeah, so it will be 2. Okay, so 25 to 30, it will be 2. Okay, no number is falling between 25 to 30 here. Okay, so it will be 2. So the frequency corresponding to that will be 2. Similarly, most of the students have obtained marks between 19 to 24, that is 11 students. Then again, that will be 5 plus 5 plus 1. Then the number of students who have obtained marks between 13 to 18 is 5. Then again, number of students who have obtained marks between 7 to 12 is 5 plus 3, that is 8. And number of students who have obtained marks between 1 to 6 is 3. So this is how you make a frequency table. I think this, it must be clear by now. Again, you have to total all the frequencies, which is equal to 30. Okay, so this is how you construct a frequency table. Now let us see how do we construct a cumulative frequency distribution. Okay, this also we will understand by a method by means of an example. So as I told you that cumulative means addition. Okay, means sum. So cumulative frequency can be obtained when we successively add all the frequencies from the bottom of the distribution. Okay, so let us see the example. So in a walking race conducted by a club, all 10 of the participants had to fill out a form that gave their personal and demographic details. Okay, participants filled in various details, but here we will consider the age for constructing the cumulative frequency distribution table. Okay, so these are the age in years of the participants: 36, 48, 54, 92, and so on. Now we have to construct a cumulative frequency distribution. Okay, so based on that cumulative frequency distribution, you have to answer the following questions. The questions are: how many participants are aged less than 45? How many participants are aged more than 44? And what is the percentage of participants who are older than 65 years? Okay, then you have to answer these questions by using cumulative frequency distribution method. Now let us see how to do this. So first of all, I'll discuss these steps, and then we'll solve the question. So first we have to divide the values into intervals and count the number of values in each interval. So what happens in this case, the intervals of 10 is appropriate. Okay, because suppose you want intervals of 10, then you can take intervals of 10 because the range is quite high. There's large variation in the ages. Okay, if you see the aged, it is as low as 36 and as high as 92. So to cover this, we can take intervals of 10. Okay, now we have to create a frequency distribution table. So first we'll go through the steps and then we will solve it. So in the first column, so let us see how we have to do it. Okay, let us see this. So what happens in the first column, you have to write the lower value. Okay, so first of all, you have divided into intervals of length 10. Okay, so suppose 85 to 94, that you count, there will be 10 values. So 85, 86, 87, 88, 89, 90, 91, 92, 93, and 94. So there are 10 values. So each is an interval of length 10. Then for each interval, you have to write the lower value and the upper value. Okay, so for the age interval 85 to 94, the lower value is 85, the upper value is 94. So let us start from here. Okay, so if you see 35, first we'll start with 35. Okay, so 35 to 44, then 45 to 54, 55 to 64, 65 to 74, 75 to 84, 85 to 94. Okay, so we are starting with the lowest value, that is 35 to 44. Again, this you see this is an interval of length 10. Okay, 35, 36, 37, 38, 39, 40, 41, 42, 43, and 44. So this is of length 10. Again, all these intervals are of length 10. So as we did here, same thing we'll do here. We'll write the lower value in this column and upper value in this column. So in the interval 35 to 44, 35 is the lower value, 44 is the upper value. Again, in the interval 45 to 54, 45 is the lower value, 54 is the upper value. In the interval 55 to 64, 55 is the lower value, 64 is the upper value. Again, in the interval 65 to 74, 65 is the lower value, 74 is the upper value. Similarly for others. So in the first column, what you have to do, you have to write the lower value. Okay, and in the second column, you have to write the upper value. Then you have to write the frequency. Okay, now we have to write a frequency for each. How we will, again, the same method which we did. So what were the ages in years? So it was 36, 48, 54, 92, 57, 63, 66, 76, 66, and 80. So these were the ages which were given. Okay, now in the age group 85 to 94, how many of the ages are lying? See, 85 to 94, greater than 85 and less than 94. So this is the only value, that is 92, which is lying between 85 to 94 age group. So this is 1. How many of them are lying in 75 to 84? Okay, means greater than 75 and less than 84. So here this is 76 and 80. So there are 2 values. So you have written 2. Similarly, then you have to find for 65 to 74. 65 to 74, one is 66 and the other is again 66. Okay, so there are 2 values. So similarly, you have to write the frequency corresponding to each interval. Then this is the sum of all the frequencies. Again, okay, now this is the cumulative frequency. Cumulative frequency here is, see, this is the sum of all the frequencies. For this, it will be 10. Okay, this is the sum of all the frequencies. Okay, so for the last interval, it will be 10. For this interval, greatest interval, it will be 10. So let us see how to calculate the frequencies. So the first, it will be 10. For this 9 will be the sum of 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 1, 9. Then 7 will be the sum of, what will be the sum of 7 here? 2 plus 2, 4 plus 2, 6 plus 1, 7. Then 5 will be 2 plus 2, 4 plus 1, 5. Then this will be 2 plus 1, 3, and this is 1. So this is cumulative frequency. Now you have to find the percentage of cumulative frequency. How you will find the percentage of cumulative frequency? As I told you previously, it will be 1 divided by the total into 100. So it will be 1 divided by 10 into 100. So how much it will be? 10. Similarly, how you will get this? 2 divided by 10 into 100. Again, 2 divided by 10 into 100, you will get 20. Again, this 1 divided by 10 into 100, that is 1. So this you have calculated the percentage. Now you have to calculate the cumulative percentage frequency. So that will be the percentage divided by total divided by n into 100. So 10 divided by 10 into 100. So here 10 divided by 10 into 100. So that will be 100%. Okay. Similarly here, this will be 9 divided by 10 into 100. So 9 divided by 10 into 100. So that will be 90%. Okay. So similarly, you have to calculate for all of these. This is the cumulative percentage frequency table. So in this manner, we find the cumulative frequency distribution table. Okay. Okay. So based on the preceding table, now we have to answer the questions. So the number of participants who are aged less than 45 years. How many participants are aged less than 45 years? So here, if you see, less than 45 years means between 35 to 44 years. So that is only 1. So only 1 participant is aged between 35 and 44 years. Okay. Now, number of participants who are aged more than 44 years. When more than 44 years means, more than 44 years means this age group, this. More than 44 years means these age groups. So again, you have to add for all these age groups. So it will be 2 plus 2 plus 2 plus 2 plus 1. Okay, so how much it will be? 9. 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 1, 9. So this will be 9. Okay. Now percentage of participants aged above 65 years. So how many participants are aged above 65 years? Means these above 65 means 65 to 74, 75 to 84 and 85 to 94. So it will be 2 plus 2 plus 1. That is 5 divided by 10 into 100. That is 50% because it's asking the percentage. Okay, so it will be 5 divided by 10 into 100. Right. So that's all. The number of participants who are aged above 65 years is 50. Okay. So this is how we do a frequency distribution table. Okay.